In this video, we are going to look at factor by grouping. Factor by grouping is a technique that is helpful when we have a polynomial or an expression with 4 terms. So with factor by grouping, the first step that you want to take is to group into 2 binomials. So looking at example 1, we group the first 2, group the second 2, we now have 2 binomials. From here, you're going to look at each of those groups and right away factor the GCF out of group 1. So in this case, between a 12x cubed and a negative 9x squared, we can take out a 3x squared. And what I'm left with is a 4x minus 3. Next, we're going to do the same thing, but now with the second group. So we will factor the GCF of the second group. Now for this one, we have a 4x and a minus 3. They don't have anything in common, so you could think of it as factoring out a 1. It's helpful to write that. And that's what we're left with. Now our last step is a little harder to see. But if you look, this is considered one big term because they're being multiplied. And that has a 4x minus 3. As well as this other piece of it here has a 4x minus 3. So here we're going to go off to the side and do a problem similar to it. Let's say I had 3x squared times 2 plus 1 times 2. They both have a 2 in common, so we could factor a 2 out of both of them. And when I pull a 2 out from here, I'm left with 3x squared. And when I pull a 2 out from here, I'm left with a 1. What we did is basically just reverse the distributive property. If I were to multiply that 2 through, I'd get this back. Ours, same exact idea. They both have a 4x minus 3, so we get to pull that out. That ends up being the greatest common factor, is this binomial factor. What we're left with out of this first part is a 3x squared, and the second part we're left with a 1. And so that last step is to factor out the common binomial. Okay, so let's go ahead and look at example 2. So first step, factor by grouping, group into 2 binomials. Next, we need to take out the greatest common factor for each. So looking at this first one, we will end up being able to take out a 4x squared. We are left with a 3x plus 1. Very similar to example 1. There is not a common factor other than 1 for us to take out. You know that you did it right if you're left with a common binomial. So we can pull that common binomial out. What I'm left with from my first term is 4x squared, and then we have a plus 1. Okay, looking at example 3, group the first 2. Now there's always a lot of question as to whether or not we include this negative. So maybe you can hold off if you're not quite sure and pull out the greatest common factor of our first binomial. We will pull out an x cubed and we will end up getting x minus 1. Now keep in mind, in order for factor by grouping to work, we have to have a common binomial. And so I know that after I've pulled something out, I want this to be an x minus 1. Well, right now this is a negative and a positive, so I do want to group that negative with to factor out the negative 8. That would leave me with a positive x minus 1. Now you can see they both have an x minus 1 in common. We can pull that out. We're left with x cubed minus 8. we don't know how to yet, but put a star by that. We can actually factor this further, and we'll come back to that later. Okay, so with our last one, you can see that every single term has a greatest common factor. So you could try and pull something out of all of them right away, and notice that you could take out a 2x. We would be left with a 5x cubed minus 10x squared plus 3x and then minus 6. Now we can ignore that 2x, but apply the factor by grouping on the inside. Group my first two, group my second two. Again, ignoring that 2x is here. Looking here, my greatest common factor of my first binomial will end up being a 5x squared. And I'm left with x minus 2. With our second binomial, I can take out a 3. I'm left with x minus 2. Now again, try to ignore that 2x. Within here, they both have an x minus 2. So I can pull out an x minus 2. I'm left with a 5x squared plus 3. So that would be considered completely factored from here. But let's say you missed the greatest common factor. We'll redo this problem in another way. If you completely missed that, factor by grouping should still work. So group my first two. Greatest common factor is 10x cubed. I'm left with x minus 2. Next one, greatest common factor ends up being a 6x. I'm left with x minus 2. From here, they both have an x minus 2 in common. I'm left with a 10x cubed plus 6x. Again, if you did it this way, we can put a star by it. We'll come back, but this is not considered fully factored. So that's factor by grouping. And one method that's kind of cool that factor by grouping is used for is to factor just basic quadratic equations. We went over the diamond box, but you can actually use the diamond and factor by grouping together. So same idea, you take your A times your C, and that ends up giving you a negative 18. You look at your B value, that goes down here. And so you want to multiply to get negative 18, 2 times negative 9, and add to get 3. And so the numbers that will do that for us are 6 and 3, where we want the 3 to be negative and the 6 to be positive. So what the diamond ends up finding us in this case is how these x's split up. So you could rewrite this expression as 2x squared minus 3x plus 6x minus 9. So basically we're writing out the quadratic before we combined like terms. Well, now that we have 4 terms, we can use factor by grouping. Group the first two, group the second two. Pull out the greatest common factor, which is x. We're left with 2x minus 3. Pull out the greatest common factor here, which is 3. We're left with 2x minus 3. Now, we have that 2x minus 3 in common. I'm left with an x plus 3. So again, this is an alternative to the diamond rectangle. Take those values that you found that we would normally plug into the box, the negative 3 and the 6. That tells you how to split apart your x's. Now you have 4 terms and can use grouping. So to do another one, we have 9 times 21. That will end up giving us 189. So I need to multiply to get 189, but add to get 66. That will end up giving me 3 and 63. Both will be positive. That tells me how to split apart the 66x's. So 63x plus 3x. And I still just have 21. From here now, factor by grouping. Factor out our greatest common factor here. That would give us a 9x. We'd be left with an x plus 7. From here we can take out a 3. Also left with an x plus 7. From here they both have an x plus 7, with a 9x remaining from the first one, a 3 remaining from the second.
So why